Hello friends, welcome back to the second session on comparison between TIA Portal and CX Programmer. Okay, I have two programs opened up already here. One is TIA Portal and CX Programmer. So in this, we will start from beginning, just a refresher to add all no contacts and output coils. So before starting anything, what I will do, I'll edit my symbols. I'll name the symbols input 0.00 as start, motor 1, start, motor 2. Then I'll go to 100. The output coils are beginning with address 100. I'll go to 100 here. I'll put motor 1 started, motor 2 started, right? So now I'll go to section here. I'll add a NO contact. So this is going to be my 0.00, which is start motor 1. I'll put an output coil here, which is going to be my 100.01. Sorry, this is 0.00. I'll put output coil here. It is 100.00. Motor 1 started. Then on the second network, I'll put 0.01. Motor 2 start, and I'll give an output coil as 100.01, which is motor 2 started. Right. Let's do same thing with TIA Portal. Here I have to define my PLC tags first. So I'll do show all tags. I'll add I 0.0. Sorry. Start motor 1. So this is going to be my I 0.00. Start motor 2. I 0.1. motor 1 started. So now it is I 0.2. So I'll change it to, either I can go from here and name it as a Q, or else I'll straight away change Q 0.0. Then motor 2 started, which is going to be my Q 0.1. Going to OB1 now. I'll put NO contact here. So this is my I 0.0. which is start motor 1, and the output I can directly name motor 1 started. Right, on the second network I'll put one more contact, which is start motor 2, and output coil motor 2 started. So these are the both programs, similar ones. This and this is a CX Programmer for Omron PLC. This is for your Siemens PLC. So to test this, what I will do, I will start the simulator, right? So what I'll do, simulation work online. So once I do this, my simulator will start. So see that the simulator has started. It is waiting for these inputs to be toggled to on. So this I will do, force on, my output comes on, force off, the motor goes off, force on, output motor 2 started is on, I'll do force off, right? So to remove all the forces, what I'll do, cancel all. So in TIA portal, here let's start my simulator. Here to start simulator, I'll click here. Okay. Load. Start module. Finish. Let's monitor this. To monitor this, I'll click on a small little specs here. Now let's check your memory. Can I do this modify to 1? No. Why? Because this is physical input. Now to force the physical inputs, what I have to do, I have to go to watch table and force table. Right? On the force table, I'll have to define these two inputs here. So what I'll do, I 0.0, then I 0.1. Correct? Now I'll have to give the force value true. Note that both these inputs are checked. So for now I'll keep only one to be force. So I'll monitor this, then I will do the force. So once I do this, it comes up with a warning, motor 1 is on, right? So I'll remove this, force off, okay, then I remove this and give this, then force on. The second motor has started, so I'll remove force. Now let's there's one point I did not clearly mention to you all, that in Omron PLC the addressing for the inputs and outputs is fixed. Like all my inputs will start from 0.0 and ends with the outputs are always starting with the address 100.0. If I use some other name here, number, it's going to be a memory. Right? For example, if I use one more here and I'll say 200, so this is going to be my memory. Note that all these inputs are prefixed by a letter I, the outputs are prefixed by a letter Q, whereas when I put 200, it is just showing 2.00. that means it's an internal memory. If I put output here and then say 200.0001, then it's going to be a memory, internal memory. So what I mean to say is, in the Omron PLCs, all the inputs are always fixed addressing, which start from 0.0, outputs with 100.0. Remember this. For this, I will delete for now. Going to the Siemens PLC. Siemens PLC. In Siemens PLC, remember we started the address with 0.0. How we got this address as 0.0? That is because by default all the inputs and outputs are starting with the address. To know the default setting, what I'll do, I'll click on PLC, right click on it and go to properties. When I go to properties, you see all the addresses here, digital input and outputs. Its address is by default, it is starting from 0 and ending at 1.7, and output address is also starting from 0 and ending at 1. So to change this, if I can change these addresses in Siemens PLCs. How we do that? Let's do. So first of all, I have to go offline. My Siemens should be in offline mode. Then I go properties. See, now I can change this address. If I say 10 and enter, so it asks me whether you want to change this address in your program also. Do not change tags, or you can revert the tag. If I say revert the tags, if I say OK, then you see the difference. All my inputs are starting with 10.0, 10.1 and all. Now, if I see my force table, let's try to monitor this. So before monitoring, what I have to do, I have to download this program, the change program, into the PLC. Load, then start. Now let's watch table and program together. Now let's monitor this program. Right now at this stage, if I try to monitor this, I will monitor, and what I'm trying to force is I 0.0. If I force it, it says yes. You see, this has not forced to on because the address has changed to 10.0. What I'm trying to force is 0.0, right? So what I will do, I'll add one more here, I 10.0, and put the value as true, and then try to force. What I'll do, I'll force it. I'll use this as also force 10.0. Then I will go force, try to force it, yes. See that 10.0 has become on now. So this is how you can change the addresses in Siemens PLCs. Hope this is clear to you. What I will do, I'll go offline and then I'll go to PLC just to maintain both programs of CX program and TIA portal. I'll keep this address as 0. So what I'll do, I'll keep this as 0, right? Then it's asking me rewire. So all my inputs have changed to 0.0 now, right? Now this one I have to download it again. Clear? Now let's see. If I try to force, monitor this first, put this in monitor, let's force now. This is enabled. Let's force all inputs together. If I force, right, see now, right, I tried forcing it, I force it, but this has not gone into force. Why? Because in the properties I have changed the PLC address from 0 to 10 to 0. What I have to do to take this effect into the PLC, I have to go download the hardware. Anytime if you change the properties of the PLC, what you have to do, you have to download to device, hardware and software. So once I do this, right, there's some error. Looks like there are some errors here. What are the errors? Q0.0. Let's compile this. 0 errors. Right. Then I'll stop the PLC. Then what I'll do, I'll go download to device, hardware and software. So the loading will be performed on a simulated PLC. Right. Refresh, cancel. Let's delete this. Alright, save. PLC, download to device, hardware and software. Let's see. Today will not perform because preconditions are not met. Why is that? Properties 0 and 0. Motor 1 has started. Let's see. Delete. Then what we will do, monitor. I'll remove all the force. First of all, I'll remove all the force. Now, what I'll do, I'll stop PLC. Okay. Then I'll go and do download to device. Go offline, PLC. Download to device, hardware and software. Load. Start. Now let's see. I'll put this in online mode. Right. If I go here and monitor, at this stage if I force it, both my inputs are on because both are checked here, right? If I remove force, then if I do one by one, only one output should come on, which is motor 1 started, right? Hope this is clear to you. So I'll remove the force first, then I will go back to this program. Hope this is clear with addressing. Now let's do some additional functions. I'll go with CX program here. Let me delete this first and delete this. So let's do some additional features in this programming. For that, what I will do, let's start with the timers. If I want to add a timer here, right, I can click here. Then there are different types of timers in CX programmer. So to see the timers, what I will do, details, find instruction. Then I'll go to timer and counters. So if you go here, it starts with the counters, then timer. If I click on TIM, it tells me that this is a 100 millisecond timer in BCD format. That means this timer to start with is a 100 millisecond. Anything extra time you want, you have to multiply that unit with 100 millisecond. It will give you that particular time setting. There are different timers. Time, TMH, this is 10 millisecond timer. High speed timer, BCD time. BCD is binary coded decimal. Then this is again 10 millisecond timer but in binary format. So there are different types of long timer, binary. So to start with, we'll go with TIM. Then I'll have to define the timer number. So I'll start with 0. This is my 0 timer number 0. I'll say OK. Now see, it still shows me red here. Why? I'll have to give some timing to this. So set value is the time, at what time you want to set, right? So this is my time 0, and the time setting is set with the prefix of hash. So how much of time delay I wanted, this is on delay timer. How much of a time, remember this is 100 millisecond. If I click 50, so this becomes 5-second timer, right? Because 50 into 100 is 5000, which is 5 seconds. Let's test this, right? So this has become 5-second timer. Here again, if I put timer, click here, you can directly type tim, right? Timer number 1 space hash say 20. That is, this is 2-second timer. Let's try this. So this is timer number 1, this is timer number 0. So what I'll do, I'll start the simulation again. Work online simulator. Alright, see now if I do the force here, force on 1, 2, 3, 4, 5, right? This became on. If I unforce it, force off, then force. So for you to clearly understand this, what we will do, we'll add some outputs to this, right? So I'll add a network 1 here now. So input, what I'll give, timer 0. T0 is my timer 0, right? So with that, I'll start a motor output. What I'll do, 100.0, which is motor 1 started. Let's see these things together now. Then I'll put one more input here. This is going to be timer 1, right? Then my output is going to be 100.01. Motor 2 started. So let's monitor these two things now together here. Right. So I'll start the simulation. Work online simulator. Right. So let's force now. Force on. Say 1, 2, 3, 4, 5. After 5 seconds, this became on. Right. So I'll stop it. Force off. So the moment it is off, my output is off. Let's try this. Force on. This is 1, 2. Within 2 seconds, this came on. So whatever multiplication it did, hash 20 is 2 seconds, hash 50 is 5 seconds. Oh, now let's check this function in TIA portal. So in TIA portal, first of all, I'll go offline on this. Okay, then I'll remove this. So to add timer here, I'll go to instructions. See, in the instruction, you have all these functions here. Now to choose timer, there are different types of, basically there are 1, 2, 3, 4 types of timer. TP, pulse timer, T on delay timer, T off delay timer, and TONR, on retentive timer. So in this, unlike in CX programmer, the time is always on delay timer. If you have to get the off delay timer, you have to build a logic here slightly different, right? So let's first of all see on delay timer here. This is my on delay timer. I double click on delay timer. So the timer starts. This is EEC timer DP generated here. Say OK to this. Then what I'll give, I'll have to put only 5 seconds. If I want 5, then yes, right? Once I do this, this is 5-second timer. If I just type 5 and enter, this becomes 5 millisecond timer. So I want 5-second timer. So this is elapsed time. We'll see what this is. I can directly put my output coil here. So this is my motor 1 started, right? Again here, I'll put time on delay timer. Right. So this time this is going to be 2 second on delay timer. Right. These changes I'll have to download to my PLC simulator in this case. Say load. Now I'll start monitoring. Right. So now to start this, what I need to do, I have to open my force table. Right. So let's monitor these two together and see how it works. So now this is my one by one will do. First I 0.0, I'll force it. Okay, now 1, 2, 3, 4, 5. After 5 seconds this has become. Please see that this is showing me exactly timer. Unlike here, if I force it, this is showing in terms of numbers. If I do force on, this is showing the BCD number equivalent to my 5 second. Whereas in TIA portal, if I force this also, let's see, it directly shows me the real time. Okay, so you see 1 second, 2 second. After 2 seconds, this became off. So if I do this again and then force it again, see, watch this, 1 second, 2 second, 3 second, 4 second and 5 second. After 5 second, this became on. So this is pretty much what it is, difference between timers, right? Force off. Now I will remove this force, clear, force, clear, cancel all forces. So this is how the timers are programmed in CX program and TIA portal. So we will see in next video how to do off delay timer. Like once I start, when I switch off any input, the timer should start after my input is gone off from on condition. So please wait for my next video. We'll continue this timer and the counters and some additional features. Okay, probably let's do one quick exercise as well. Okay, here, so there are something called flash bits or special bits inside these PLCs. Quickly do that and then we'll close this session. So what I'll do, I'll delete this, right? Simulation, work offline. Okay, let's add one more additional network here. So I will give one input here, right? See, what it is like I'm trying to explain is there are some special functions. If I go to symbols here, see, there are some built-in functions in Omron PLCs. This particular bit P_1 minute is Boolean type of bit, which is 1 minute clock pulse. It gives a clock of 1 minute. This gives me built-in pulse of 1 clock pulse bit. Likewise, there are a lot of functions here. So for now, I'll go with this clock pulse bit. How to program this? So if I go to section here, I'll put the NO contact, then I'll click here. So it gives me built-in functions. So this P01 second is 1 second pulse. Say okay for this. So this is 0.1 second, right? 0.1 second. Let's go with at least 1 second pulse, right? So I'll put here and then I'll browse. This is 1 second. So this is 1 second pulse. It is 1 second pulse. Then I'll take an output here. So this time I'll define it as 200. This is just a memory bit. This memory bit. Let's see how this works. Okay. Then I'll close. So now I'll start my simulation. Work on simulation. Now watch. This particular output is pulsing at a rate of 1 second. This is built-in function, right? For example, if I want to start this particular output, if I have to start this I wanted output 100.0 to flash at 1 second once I start the motor, and after that time is elapsed, I wanted this to flash at a pulse of 1 second. How we will do that? Simulation, work offline, right? Here I will put one no contact, which is going to be my 1 second pulse, right? So this way my output will start flashing after this time has elapsed. So let's see this. Work online. Right, so I'll start this force in, force 2 on. So 1 2 3 4 5. So now see this, after 5 seconds this started flashing, right? If I stop, it will stop flashing. It will stop flashing. So these are the special functions in Omron PLC. Same way in TIA Portal we have similar functions. So let's see how that works. Right, now to enable these built-in functions, every time what I have to do in Siemens PLCs, I'll go offline. You will have to enable these functions in my hardware settings, right? So to do that, what I will have to do, I'll have to go back again to PLC, right click, properties, then there is a function called cycle and clock memory. So I have to enable, we will see this, what enable the use of system memory, we'll see it in next session. But for now, clock memory. If I click on clock memory, so it tells me that it generates a clock of 10 Hz, 5 Hz, 2.5, 2 Hz, 1.25 Hz. So 1 divided by Hertz is second. So if I say 1 divided by 1 Hertz, that means it is clocking at 1 second pulse, right? It's not necessary that it should start with 0. I can change it to any number I want. If I say 10, so my memory bit starts from 10.0, 10.1, 10.2, 10.3. So let's keep it as a 10.10. So now once I start this should start pulsing at a rate of 1 second. To do that, I'll put 1 here, then I'll say memory 10.5 because we used 10 as a clock hertz, so it becomes 1 hertz clock, right? So same here, if I put no memory 10 point, say if I give some other number 0.3, so this will be pulsing at a rate of 2 hertz. So once this is done, what I have to do, because I changed the properties of this PLC, I have to right click, download to device, hardware and software. Right, load. Finish. To monitor this, I'll go to force table again, then split the windows in two. Let's monitor these two. Monitor and force table monitor. So both our inputs will go in force at the same time. So let's see. See, although this is pulsing at a rate of 1 second, but my output is not on. Why? I'll have to start the motor from here first. So if I do force, yes, 1, 2, 3, 4, 5. After 5 seconds, it will start flashing at 1 second. Right? Go flash off. And then see this one. This is 1, 2. After 2 seconds, this is pulsing at faster rate than this one, because this clock is 2 Hz, this is at 1 Hz. This is built-in functions in TIA portal, similar to what it is in CX program. The only difference is how you enable them, how you use them. That is the only difference. That's why I always keeps telling my students that once you learn any one PLC programming, you will be able to catch up with the other brand, other software very easily. You should know the concept basically. It's not necessary that you have to go and learn each and every brand of PLC programming. Once you know one brand of PLC programming, you can easily cope up with the other brand of PLC. Hope this is good for you for today. So I'll be doing further sessions on Omron to Siemens PLC comparison. Please watch these videos, like and share with your friends, spread the knowledge. And as I've told you before, if you wanted to do the detailed programming sessions on it, we are always available with you. You can always write a mail to us, WhatsApp. Your requirement, we'll get back to you very soon. Thank you very much for your attention and time. Good luck.